afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering, Chevron Engineering College. Today I am going to explain inversions of the kinematic chain, and we have left two important mechanisms in the inversion of single slider crank chain mechanism. This is my 8th lecture video regarding to the subject kinematics of machinery. So in the last classes we have discussed about the different types of mechanisms on single slider and double slider, sorry, 4-bar chain, and inversions of the single slider also. So we have seen pendulum type, oscillating cylinder engine, and rotary internal combustion engine. In today's class, I am going to explain about crank and slotted lever quick return motion mechanism. So this is one of the most important mechanism in the first unit regarding to the problems also. So they are giving problems on this mechanism also. So coming to the mechanism, it consists of a slotted bar. So you can see it in the figure that this is the slotted lever quick return motion mechanism, crank and slotted lever mechanism. So this is the crank which is in between the two positions, that is AP1 and AP2. So these are the two fixed beams and this crank is in between that, and lever is, that is the slotted bar is on the fixed position at B point, and P is the position, P is the initial position of the slotted bar from the two ends, and it consists of a ram which is connected to the P, that is the slotted bar, with a connecting rod, and this ram consists of a cutting tool which is used to cut at the line of stroke, and this motion mechanism consists of two strokes, that is the cutting stroke and a return stroke. So by the two ends it can be cut. So this is the major portion in the crank and slotted lever quick return motion mechanism, and the angle between the slotted bar and the initial position is 90 degrees minus alpha by 2. So alpha is the angle existed by the fixed link and the position B2. So you can see in the picture also, alpha is the angle generated between fixed link, that is the A and C is the fixed link here. So AC is the fixed link and CB2 is the another link. So that two positions, the angle between the two positions is called as alpha. And the angle between the two positions, that is BC and B2, is called as beta. So that is the two positions. So 90 degrees minus alpha by 2 is the angle between the fixed link and the slotted lever lever bar and the fixed position, that is AP1. So that angle between the AP1 and the fixed link is called as 90 degrees minus alpha by 2. And when the stroke is returned from the P1, so when it is the slotted bar is at the P1 position, the ram is at R1 position. So that is the initial position. So before the initial position R1. And when the slotted bar position changes from P1 to P2, and the ram also changes from R1 to R2 in the line of stroke. So that is in the line of stroke, they are going to change its position. So that is called as cutting stroke. So from the position P1, when the slotted lever bar comes to P2, it is called as cutting stroke. So initially the ram is connected to the slotted bar with the help of a connecting rod. It also moves in the line of stroke. So that is the cutting stroke. And when the position of the slotted bar comes from P2 to P1, the ram also moves from R2 to R1 position. So it is called as return stroke. So these are the general basic function of this crank and slotted lever quick return motion mechanism. So the working can be seen in the animation in the next slides. So, but this is the basic functions and parts of the mechanism. So here there are four links. Link one is the slider, that is the slider in the slotted bar, and link two is the crank, which is moving in the clockwise direction, and link 3 is the fixed link, that is the AC position is the fixed link, and link 4 is the slotted bar. So total 4 links. Link 1 is the slider in the slotted bar, link 2 is the crank, link 3 is the fixed link, that is AC. So we have to fix a link in the total 4 links, that is why we are fixing the AC position, and link 4 is the slotted bar. So these are the four links. So basically this crank and slotted lever quick return motion mechanism is used in the shaping machine. So you all know about the shaping machine. There we can use the crank and slotted lever quick return motion mechanism. So generally this mechanism is mostly used in shaping machines and slotting machines and in rotary internal combustion engines. So generally they are used in these all engines. And in this mechanism, the link AC, that is the third link forming the turning pair, is the fixed link. So you can see it in the picture also. AC is the fixed link here, and it is also forms the turning pair. So that is attached to the crank, and the link 3 corresponds to the connecting rod of a reciprocating steam engine. So this affects to the connecting rod of a reciprocating steam engine, and the driving crank CB revolves with uniform angular speed about the fixed center C. So you can see it in the picture. CB is the crank here. So CB is the crank position which is driving on the forward and backward motion. So like the wipers, but B position is the slider here. It moves on the forward and backward direction only. Then the crank moves in the front and back positions. A sliding block attached to the crank pin at B slides along the slotted bar AP. So that is the AP position. So AP is the slotted bar position and B is the slider in the AP. And thus it causes AP to oscillate about the pivoted point A. So from the pivoted means attached. So pivoted అంటాము ఫిక్స్ చేసిన పొజిషన్ ని pivoted పొజిషన్ అంటున్నాం. So which is pivoted at the point A, and this slotted bar is used to wiper. So that is oscillating. So ఇట్లా మూవ్ అవుతుందమ్మా మనకి. సో డైల్ గాని మూవ్ అయినట్టు AP అనేది P1 P2 పొజిషన్ లో మనకి ఇట్లా మూవ్ అవుతుంటారు. డాటెడ్ లైన్స్ లో చూడొచ్చు మీరు. నెక్స్ట్ a short link PR transmits the motion from AP to the RAM. So PR means P is the endpoint of the slotted bar and R is the RAM position. So PR is the connecting rod which is used to transmit the motion from AP to the RAM. AP అంటే మనకు స్లాటెడ్ బార్ అమ్మ. ఈ స్లాటెడ్ బార్ నుంచి RAM కి మనకి మోషన్ అనేది ట్రాన్స్మిట్ చేయడానికి PR అనే కనెక్టింగ్ రాడ్ అనేది యూజ్ చేసుకుంటాం, which carries the tools and reciprocates along the line of stroke R1 R2. So R1 R2 is the line of stroke, as we have already explained. The line of stroke of the RAM is perpendicular to the AC produced. So AC is the fixed link here and R1 R2 is the line of stroke which is perpendicular to the line AC. So these are the major considerations. And next, in the extreme positions AP1 and AP2 which are tangential to the circle, and the cutting tool is at the end of the stroke, and the cutting tool is end of that stroke. So AP1 AP2 అంటే మనకి ఏ అంటే ఫిక్స్డ్ పొజిషన్ అమ్మా, P1 వచ్చేసరికి ఈ పాయింట్. సో AP1 and AP2. So these are the two tangential points for the cutting stroke. The forward or cutting stroke occurs when the crank rotates from the position CB1 to CB2 in the clockwise direction. So ఎప్పుడైతే మనకి కటింగ్ స్ట్రోక్ లో కట్ అవ్వాలనుకుంటున్నామో AP1 నుంచి CB1 CB2 లోకి మనకి కట్ అవుతుంది అనమాట. CB1 అంటే మనకి crank position అమ్మా. So this is the C point and B1. B1 అంటే లెఫ్ట్ సైడ్ ఉంది చూడండి, ఇక్కడ ఈ పాయింట్ B1 అనుకుంటున్నాం, అండ్ CB2. సో ఎప్పుడైతే ఈ క్రాంక్ స్లాటెడ్ బార్ అనేది ఇట్లా ఆసిలేట్ అవుతుందో ఈ క్రాంక్ కూడా మనకు ఆసిలేట్ అవుతుంది. సో ఎప్పుడైతే క్రాంక్ ఆసిలేట్ అవుతుందో ఈ స్లాటెడ్ బార్ కూడా దానికి కనెక్ట్ అయింది కాబట్టి అది కూడా ఆసిలేట్ అవుతుంది. నెక్స్ట్, the return stroke occurs when the crank rotates from the position CB1 to CB2. సో మళ్ళీ రిటర్న్ స్ట్రోక్ వచ్చేసరికి బ్యాక్ సైడ్ ఉంటుంది, ఒకసారి మీరు చూడొచ్చు. సో CB2 నుంచి CB1 కి రిటర్న్ స్ట్రోక్ అనేది ఉంటుంది ఇన్ ద క్లాక్ వైజ్ డైరెక్షన్. సిన్స్ ద క్రాంక్ హ్యాస్ యూనిఫామ్ యాంగులర్ స్పీడ్. సో క్రాంక్ అనేది ఎప్పుడు కూడా మనకి యూనిఫామ్ స్పీడ్ లో ఉంటుంది కాబట్టి దీనికి ఫార్ములా ఉందమ్మా మనకి. సో therefore time of cutting stroke by time of return stroke is equal to B by alpha. సో కటింగ్ స్ట్రోక్ మొత్తాన్ని కూడా మనకు ఆల్ఫా బీటాగా తీసుకుని రిటర్న్ స్ట్రోక్ మొత్తాన్ని కూడా ఆల్ఫాగా తీసుకోవచ్చు. సో దట్ ఈస్ బీటా బై ఆల్ఫా. we can take it as beta by 360 minus beta. సో బీటా బై 360 మైనస్ బీటా, ఎందుకంటే బీటాలో నుంచి మిగిలిన యాంగిల్ తీసేయాలంటే టోటల్ 360 డిగ్రీస్ కదమ్మా. సో 360 డిగ్రీస్ లో నుంచి రిమైనింగ్ బీటా తీసేస్తే సరిపోతుంది. దట్ ఈస్ 360 మైనస్ బీటా. We can also write it as 360 minus alpha by alpha also. So when you are having the alpha angle, you can write down also like that. So that is the formula for uniform angular speed of the crank. Then, since the tool travels a distance of R1 R2 during cutting and return stroke, therefore travel of the tool or length of the stroke is written as R1 R2, that is the stroke level, line of stroke, that is R1 R2, and which is equal to the position of P1 P2, that is the position of slotted bar, that is equal to 2 into P1 into Q. సో 2 ఇంటూ P1 ఇంటూ Q. సో ఈ లెంత్ ని ఇక్కడ మనం తీసుకుంటుంది P1 P2 పొజిషన్ ని ఇక్కడ R1 R2 కింద తీసుకుంటున్నాం అమ్మా. 2 ఇంటూ P1 ఇంటూ Q గా తీసుకోవచ్చు. సో డైరెక్ట్ గా P1 P2 తీసేసుకుండా 2 టైమ్స్ ఆఫ్ P1 ఇంటూ Q, which is the Q is the midpoint of the mechanism. సో అట్లా తీసుకొని డెవలప్ చేసుకుంటూ వెళ్ళిపోతే ఫార్ములా లాస్ట్ ఇది వస్తుందమ్మా. సో 2 ఇంటూ AP ఇంటూ CB బై AC. CB is the crank position and AC is the fixed link, and AP is the length of the slotted bar. So AP is the length of the slotted bar. AP is the length of the slotted bar. Now we can see the animation, how this mechanism is working. So this is the slotted bar, in which you can see it in the blue color. Green color one is the crank, and brown color, that is pale brown color, which is the connecting rod, and this is the cutting stroke, that is the line of stroke, and this is the cutting tool here. So you can see the working of crank and slot lever quick return motion mechanism. So let's see the another example here. So there you can see the formula, time of the cutting stroke by time of the return stroke. So angle A by angle B. So in the slide we are taking it as beta by alpha angle. So this is the point here. This is the B point and center one is the C point. So this is the crank position. This is the slider here. B is the slider here. You can see it is sliding in the slotted bar. You can see how we can weld it with a wooden bars. So this is functioning manually without any motor or external force. That is the slotted bar, and that is the slider which is connected to the crank. So when the crank moves in the clockwise direction, the slider in the slotted bar moves. Next we can see the Whitworth quick return motion mechanism. So this is the figure of the mechanism in which it consists of two cranks. So this is the large crank and this is the small crank. So in this is the axis line for the mechanism, and this is called as line of stroke, in which the ram is connected to the connecting rod, and this is the slotted bar, which is taken as the link 1. Link 1 is the slotted bar, and link 4 is the slider, in which it is connected in the slotted bar, and link 2 is the fixed link here, that is the DC position is the fixed link. So total four links are there. So link 1 is the slotted bar, link 2 is the fixed link, and link 3 is the connecting rod, sorry, the crank, and link 4 is the slider. So total four links between two crank positions. In this mechanism also, it consists of two strokes, that is the cutting stroke and the return stroke, in between the points R1 and R2. So R1, R2 is the line of stroke points of the ram for the cutting stroke and return stroke. And the formula for the Whitworth return motion mechanism is time of the cutting stroke by time of return stroke, that is alpha by beta, which we can take as alpha by 360 minus alpha. So we can take it also as 360 minus beta by beta. So that is the general formula. This mechanism is mostly used in the shaping and slotting machines. And in this mechanism, the link CD, that is the second link, forming the turning pair is fixed. You can see it in the picture also. DC is the fixed link, and it is considered here as link 2. And the link 2 corresponding to a crank in a reciprocating steam engine, and the driving crank CA rotates at a uniform angular speed. So it rotates with the uniform angular speed, and the slider, which is the link 4, attached to the crank pin at a, slides along the slotted bar PA. So it is sliding over the slotted bar PA, which is the link 1, which oscillates at a pivoted point D, which is oscillates at a pivoted point D. So these are the links and working of the link, and the connecting rod PR carries the ram at R position, to which a cutting tool is fixed. So it is fixed at the cutting tool. The motion of the tool is constrained along the line RD produced. So which is produced through the RD line. So RD is the position of ram and the fixed position of slotted bar. Fixed position of the slotted bar. And the motion of the tool is constrained along the line RD produced. So RD is the line between the 2 points, and the motion of the tool is constrained between the 2 points only along a line passing through D and perpendicular to the CD, which is perpendicular to the position. PD. Next, when the driving crank CA moves from the position from the CA1 to CA2 of the link from the DP1 to DP2 through an angle in the clockwise direction. The tool stroke moves from the left hand end of the stroke to the right hand. So when it moves from the tool from left hand stroke, that is the R1 to R2 position at a distance of 2 into PD. PD means PD is the crank position of the upper crank, small crank, that is the small crank angle. Now, when the driving crank moves from the position CA to CA1, that is the position of the larger crank, that is the CA1 and CA2, through an angle in the clockwise direction, the tool moves from the right hand to the left hand direction. That is the end of its stroke. So that is considered as end of its stroke. And a little consideration will show that the time taken during the left to right movement of the ram, that is in the cutting stroke, will be equal to the time taken by the driving crank to move from CA1 to CA2, that is the larger crank. So the two positions have the same timing, that is it is equal to the time taken. Similarly, the time taken during the right to left movement of the ram will be equal to the time taken by the driving crank to move from CA2 to CA1. That is the driving crank position from CA2 to CA1. And since the crank link CA rotates at uniform angular velocity, therefore the time taken during the cutting stroke is more than the return stroke. So generally, the cutting stroke is taking the more time than the return stroke. That is, the forward stroke is more than the return stroke. In other words, the mean speed of the ram during the cutting stroke is less than the mean speed during the return stroke. So the cutting stroke speed is less than the mean speed during the return stroke. So these are the positions, different positions of the mechanism. Next, we are going to see the formula. The ratio between the time taken during the cutting and return stroke is given by, that is the formula. Time of the cutting stroke by time of the return stroke, that is equal to alpha by beta. So the angles can be seen here. This is the beta angle, which is smaller than the alpha angle, that is alpha by 360 degrees minus alpha, or it can also be written as 360 degrees minus beta by beta. So this is the general consideration of the Whitworth mechanism. Let us now see the animation working position of the Whitworth mechanism. So this mechanism also has the resemblance of crank and throttle lever quick return motion mechanism. So that is the working of quick return motion mechanism of Whitworth. So link one is the fixed link. So you can see the cutting stroke and return stroke. So S is the slider there. So these are the different types of animations for the Whitworth quick return motion mechanism. So let us see the last one. So these are the different types of mechanisms for the with co-current motion mechanism. So these are the last two mechanisms in the single slider crank chain. In the next class, we are going to see the double slider crank chain, that is the elliptical trammel, Scotch yoke mechanism, and Oldham's coupling. Thank you.